Uh, Hi everyone, I'm Dante. I'm from Sandbox in Mexico, and I will talk a little about our work in collaboration with the University of Naples. We are developing something called Sandbox apps and the workflow scheme, which we are integrating in Parsl workflow engine. I will present you the design, implementation, and the application lifecycle of this prototype. First, as introduction, we extend the Parsl workflow engine to support a new type of new app application called the Sandbox app. The idea is to isolate each task in a Scratch directory in a straightforward and transparent fashion. While we use the workflow schema to do this, which basically is a virtual space in the file system where the workflows or the tags write and their outputs and could consume their inputs. We developed this to address the following challenge. First, the definition of the task dependencies. Second, the execution of each task in an isolated sandbox. And 3, the data staging in the sandbox. So what is the workflow scheme? The workflow scheme uniquely identifies a task in the workflow. As we can observe, first is the scheme label. This is the workflow name. Then is a unique ID for each workflow executed. And then is the unique ID for each task in the workflow. And following up this is the path to the input and output directory to the task that we are referring to. We designed this workflow scheme for batch tasks, and it's used for variable files, mapping native batch applications, web applications, and even IoT applications. So we can share with this reference local files in a local file system, in a shared file system, and even perform the remote storage between different physical machines, virtual instances, or virtual containers. We do this by implementing the LN in the Linux system by copying the files with SCP or using grid FTP for remote instances. So Scratch directory is a sandbox where each application is contained and is isolated of all other applications of the workflow. So to implement this workflow scheme in Parsl, we developed a new type of application for Parsl called the Sandbox app. The Sandbox app implements the following operations. First, creates a Scratch directory for each task in the workflow. Second, resolve the workflow scheme to find out the dependencies of the workflow. 3, stage the input files for each task in the workflow. And finally, execute the command in the Scratch directory, writing the outputs of each task in the Scratch directory of the task. In this figure, we can observe how we define a Sandbox app. We use a new decorator, which is Sandbox _ app, and as a native Parsl application, the applications are defined as a Python function. Here is the class diagram of the Sandbox app. As it can be observed, the Sandbox app is an extension of the app-based class used to implement the common functionality across the native Parsl apps. The Sandbox app decorator grabs the usage of the Sandbox class, which manages the Scratch directory and the resolution of the workflow scheme. Here is an example of a workflow written with the using the Sandbox app. Here we can observe the workflow which executes 5 applications. So we define the applications as a native parse application by using the Sandbox app decorator. And then we define the inputs of each task using the workflow scheme, which is defined using this variable and the attribute of this variable, which is the workflow scheme, which logically contains the path to find out this file in the virtual spaces created by the workflow by the Sandbox task. So the advantage of this is that each application is isolated, so if the outputs of the application are not overridden by another application in the workflow. As conclusion, we propose an approach for integrating the workflow scheme in parts. We designed and implemented a new type of parse app called Sandbox app. Using this approach, we automate the data staging phases of an external software. We now implement this feature using the Parsl local provider. The idea is to extend this type of application to another providers in parts and perform an extensive performance analysis of this application comparing with another workflow engines from the literature. And this is all for me. Thank you for your attention.
Cool, thanks. If anyone's got questions, please post them into the chat and you can read them out or we'll read them out. I'll start. So can I use a workflow URL to refer to the output of a previous app that has run in my dependencies? And will that move files between the sandboxes for 2 different apps? Is that what's going on? Yep.
Yeah.
Cool. Okay. That seems nice. Does anyone else have any questions? If not, then we will.
Quick question from me, Ben.
Yeah,
so the way I saw with the schema is you basically sandbox, like in the URI, the workflow name and then the task name. Is there and I might have missed this, but is there another, do you also, because many tasks are executed many times probably, so is there a way, how do you encode that? Maybe I just missed it in the slide.
Yeah, we, for example, task is executed too many times. The workflow scheme of the Sandbox apps produce a unique ID for each execution of the task, and each execution will be isolated in a different virtual space to write and read their input and outputs.
Got it. Okay, awesome. Thank you.
Thank you too.